Greetings everyone. Welcome to lesson 3 of trigonometry for students and surveyors. We're going to continue on with triangles, right triangles. We've got to throw a few curves into the mix for you. Not curves, not literal curves, but a few different things that we didn't talk about earlier. We'll get right on that. Want to talk about these calculators. We were talking about the price of them a while back in my first lesson. I taught at the college, Lake Washington Institute of Technology, for 3 years in their winter program. Taught surveying and trigonometry, part of the civil 3D program, engineering program. I had required all my students to have HP 35S's because that was the latest iteration of their good scientific survey engineering calculator. And it didn't seem to be too much of a burden on it because they were $59. And then I started teaching again at giving some lessons at my work to the surveyors there, and they all ended up getting them. But they're now they're jumped up to $189. And I was like, what's going on with Hewlett Packard? But what I found out last night, I did some researching on this. They quit making these probably a year or so ago. So try, if you can get one, try to get one, even if that's a little bit expensive, or find one on eBay, wherever you can get one. I would recommend getting these. Are pretty amazing calculators. And then failing that, or along with that, you could have your HP 42S free download on your iPhone or your Samsung phone. And there's also manuals online. Go ahead and look online. If you're dead serious about really knowing this trig, which is very practical type of a math, you can use it all through your life, no matter what you're doing. It just pays to get into the manuals and see what these things can do, and they're a lot of fun. So that's about all for that. And then, of course, there's a manual with this. There's a disk download. And they do a lot more than trig and engineering functions. They do everything you can think of, and then some, a lot more than what I know to do. So let's get right with the triangles here. All right, I got some numbers here I need to erase, and that one, hope you didn't see those. All right, well, this first triangle, they're all right triangles. You can see they've all got the little squares in the corner of them. So you have to be able to, as I mentioned, SOHCAHTOA, TOA, sine is opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. Tangent is the opposite over the adjacent. Opposite means just it's in a line, it's a division. All right, we have that. So and then you can do the arc sine, arc cosine, arc tangent. And the key that when I exploded these triangles up on the other lessons, both of the other lessons, you can see how that all, those elements, 3 elements from each angle, you have 3 elements. From this angle, you'll have 3 elements. So that's really helps you identify what, because that's essential to be able to know what sign to use. So you see a triangle like this, and you're saying, okay, what do I got to work with here? I've got the angle from angle A. This is the vertex of the angle A. The opposite is A. You got B. We don't have an angle there yet. And then there's opposite side B. So, but we do have one side. You can solve a right triangle with any 2 sides, or one side and an angle. So we'll do that from here. So to get this side, we'll go ahead and do the cosine. We need that angle, input that angle, and then take the cosine of that angle and multiply it times that. Why is it the cosine? Well, because it's connected here, so it's the cosine. All right, so we're going to go 22, 39, 27. Actually, that's the angle. Let's start like we're supposed to do it. This is degrees, minutes, second. This is decimal degrees, so usually input it that way and then change it. You're going to get your angles in this way. So we're going to go 22.2334. They're going to convert it on your on the free HP 42. You just got to look for the convert button. It's the orange button, and the convert is right over the 5. So it'll be the 5 convert, and there's a 5. Then you want to look for HMS, then it pops you up to the top of the screen. You have HMS or HR. You want to go to HR, you're converting it to digital. All right, so in this one we're going to convert, and we got 22, 39, 28. No, I must have already done that. Oh yeah, that's right. I have 1 second off on this one, but we'll just leave it at that. All right, so we have that. We have that stored. Recall 0. I have it 22, 39, 27. Okay, so we're ready to go there. So we have that one. Now we're going to find the cosine length by using that angle times the hypotenuse. So we're going to take that recall 0 in mine, and we're going to go cosine. I got a number 09246, and we're going to go 42 times, and in yours you go times 42, 3883, 38833. We'll just round it to 3883. There you are. So there's that one. So now we've got two sides in an angle. So let's solve that one. Solve the opposite of A. So that now we have these two, we can do it two ways. We could solve this with the tangent, opposite over the adjacent. We'd have to use the tangent function, or we can use with the sine. Sine is the opposite over the hypotenuse. That's what's missing. We have the angle, so that's all we need. So we're going to recall that number. That's why you always want to try to input your numbers and store them. And then, like I say, I stored mine under 0. I've got this other angle, I think, stored under 1. Oh no, this is triangle 1. Never mind, I don't have that stored yet. So there we go. So we're going to recall that angle. And let's go do tangent. We're going to call that number, go tangent, 0.4120, and then we're going to go 38.83 times is 16. There it is, and there's 16, and that's correct. Let's double check it. We'll do it the other way now. Recall that angle, 22, 39, 27. Now let's try sine. We're going to get the sine, that's 0.3810, and then 42 times, and that's 16. So we've got it solved every which way. All right, now obviously we can get this angle here by adding this angle to 90, subtracting it from 180. But let's try it. Well, let's go ahead and do it that way, so just so we know how to do it. So recall, that's another reason by storing it, you can just pop it right in there. 22, 39, 27, plus 90, or 90 plus, and then 180 minus. And it's 67. The digital number, or the decimal degrees, is 67.6073. I'm going to store that as, don't have anything stored in 1 yet, as 1. Okay. 67.6073, sorry. I'm going to store that as 1. That box just represents my key button. Now we're going to convert that. Now they have it stored, I can convert that. So the angle, real angle, is 67, 36, 26 degrees, minutes, seconds, or hours, minutes, seconds. So there's that angle. You got it? You pretty much got it. Oh, that's oh, I don't think I did that. Oh, that's just the hypotenuse. Okay. We just did that, a squared, b squared, c squared, all right. Or no, we just subtracted from 180. That's where I got that. Okay, so let's do it this way. Now we got b. We want to figure out angle b. We can do that with a cosine. Now cosine, why is it cosine? Well, because it's connected. The c in cosine, connected. T in tangent is a right angle. So this is always good. That's going to be the right angle. That's going to be tangent. All right, so we got the cosine, the adjacent over the hypotenuse. So we're going to go 16, enter, 42, divide. That's that ratio. Now we want the arc cosine. And the arc cosine is 67, 60, 73. So we just put a tick there. That's how you do that. And we can also do that by tangent. So let's go tangent. Let's go 3883. Now this is going to be a little odd because I just rounded it off to 2 digits. As I showed you in the show in here, that's probably a very long one. So we'll go the opposite over the adjacent is the tangent. So 38.83, enter, and 16 divide. And the arc tangent is 67, 60, 58. Well, that's because I didn't store this and then recall it. So I got a slight different number. 73 to 58, that's just a few seconds difference. Then that's a good example. I'm glad that actually happened. So this is another reason why when I calculated this 3883 and I wrote it down, now I'm using that number instead of the other 2 digits, the other 4 decimal, all 4 decimal places. And you're going to get errors when you do that. You're going to get slight errors. If you have little slight errors, then you have then that's what it is. It's usually a decimal issue. Okay, so over here we have the angle and the opposite. Okay, so let's go ahead and mark these again. We'll mark these A, little a, and this will be B, and lowercase b, C, and C. Of course, we have a right angle here, so we know that's 90 degrees. Because all right angles are 90 degree perpendicular lines. Okay, so now we've been given the angle again. We have one side. So let's go from there. 48. Let's input 48, 10, 47. 48.1047, and we're going to convert that. 48, 17, 97. This time I'm going to store it as 0. I'm just going to overwrite that. Store 0. Recall 0. That's right. All right. Oh, I've already done that. 48, 17, 98. Oh, that's right. So okay. So we have that. So I have that stored there now, and I'm going to store that. Put that back over here as 0. Okay, so that's stored in 0. Now we have, what are we going to solve for? Let's solve for B. In B we have the opposite over the adjacent. So that's the tangent. We're going to solve, so we need our tangent function. So recall your angle, 48, 17, 97, 98. And now we're going to go tangent. And now we're going to have to, oh yeah, this is it. This is what I wanted to show you. This is what happens. If you'll notice that it's 48 degrees, that's over 45. If it's over 45, you either have to divide, like we did with the hypotenuse the other day, or you have to use the 1x function. And that makes it very simple. How do you know? Like if these are very, very close in length to each other, how do you know this one's longer than that one? Well, the angle, 45. If it's anything less than 45, if it's 45-degree angle, and I think you guys all know that, these two sides are exactly the same. Anything less than 45, then this line's going to be less than this one. Anything over 45, this one's 45. So we hit 1.116, we're going to hit 1x, and now we're going to multiply times 38. 38 times, and let's see, what do I have here? That's what that is. That's 34. Use 34.0, but I'll just call it 34. All right, so there's that one. So that's how you do that. So keep that in mind when you're solving these. The other way to do that is divide. Let me think how to do that. Divide, I would go 38, enter, recall that angle, and go tangent, and then divide. And that also gives you 34. I use 1x because then everything's multiplication. I don't have to, it's whatever you like. Practice, and whatever you stumble on, whatever you think is the easiest to do it that way. But that's the easiest way for me, is to just to get 1x, reverse it. If it's over 45 degrees, makes it very simple. Okay, we got that one. Now we need this guy here. We need the hypotenuse. We have this angle. So what function are we looking at? I'll give you a second there. Remember, we're looking at this angle, and these two lines connect at that angle, so it has to be the cosine. All right, so we're going to recall that angle, 48, 17, 97. We're going to hit cosine, and again, it's 0.6668. Well, so you know this isn't going to be shorter than that line. It's going to be longer. It has to be. It's the hypotenuse. So just hit 1x. 1.4997, and now 34 times is 50.9901. What do I have here? 4904. And let me try this again. 48, 17, 98. 98 cosine 1x 34 times, I got 50.99. Okay. I'm going to check that one because I must have wrote something else down. I remember I did have a different angle here, and I think that's where this comes from. That little error. I'm going to put a little red mark there. I'll check that. All right, so there's that one. We've solved that one now. We need to get this angle here. So now we're down here. Again, we're going to do the opposite. We'll do it, we can do it tangent, or we can do it sine. Let's go with sine. The sine is the opposite over the hypotenuse. We're going to try it. We don't have this angle. Now we could get it by a squared, b squared, c squared, but we don't have it, so we're just going to do that now. So we're going to go the opposite over the hypotenuse is 34, enter, 50.99, divide is 0.6, and then we want 0.666, and we want the arc tangent, arc sine of that, arc sine of that, 4182.04, and that looks good. And let's write it over. 41.204, and I'll store that. That's now going to be my new 0. No, I'll store that as 2. store it as 2. And we're going to convert that. Recall 2. Yep, that's correct. Then we'll put this in hours and minutes. 41.49, oh not a point, dash 49-13. And of course the other way to do that would be 41 degrees, 49 minutes, 13 seconds. But when you're manipulating the numbers in your calculator, you got to go with the digital, and then, or the degrees, decimal degrees. Okay, so there you are. So there's your angle there. So we got everything solved, looks like. 4182.04, that's this arc. Okay. Now we can go add our angles up. We can recall 2, recall 0. So let's go do that. Recall 2, enter recall 0, plus, that's 90. I ended up with 1 second, 90.0001. And that's because I think I rounded. Again, that's a decimal rounding error. And of course, 90, these two angles add up to 90, and that one that's 90, that's 180 degrees, so that's a check. Okay, the last one for the day is triangle number 3. Let me get this chair out of here. All right, triangle number 3, we're going to solve for this angle here. Let's call that A. Opposite A, call this one B. Opposite B. C, opposite C. Again, we could do the Pythagorean theorem. No, we can't because we don't have that. We don't have this. Pythagorean is A squared, B squared, C squared. We already got C. All right. You can do that in reverse, but we'll not get ahead of ourselves here. All right, so how do we find this angle? Light went out, honey. The light went out. Uh-oh. Damn it. The light went out. Yeah, still don't think it's bright enough. All right. I think the light's still bright enough. We'll get through this one real quick then. So how do we find this angle with what we got here? We've got the opposite and the hypotenuse, so that's the sine. All right, so we're going to go, I'm going to rush through here, 27, enter, 35, divide, 774, arc sine is 50, 48, 23, 50, sorry, decimal, 48, 23, and I'm going to store that. I could probably use a little more light here. 50, 48, 23, I'm going to store that as 4. Okay, now we'll convert that. $50, 28, 56. 50 degrees, 28 minutes, 56 seconds. That's that guy there. Now that we have that, we can solve for B. Let's solve for B. So we would want to either use the cosine, because these are connected. We have to use a cosine, or we'd have to use the tangent. We'd have to use the tangent. Okay, so let's go with the cosine. All right. So we're going to recall that number. Recall 4, 50, 48, 23. Cosine 0.638, and 35 times 2227. Correct. So that is 22.2711. And I'm going to store that as 5, just because I got the extra digits, the extra decimals there. And we're going to store that as 5. All right. So there you have, all the sides are figured out. So we could do a squared b squared to get the triangle, or we can come up here and do this all over again. So let's just go ahead and do this. Angle B, we'll use the cosine because it's connected. Here's where it connects. We could use the cosine, or we could use the opposite. Let's use tangent this time. All right, so recall 5, it's easy to mess that up, and 27 divide, got 0.8249. Now we want the arc tangent of that. Go arc tangent is 3951.77. And I'll store that as, what do I got? I'll store that as 6. Just call that a 6. Now I can recall that out. And I can also convert that. Okay, recall 6 and 393104. 31-04. Now we've got that angle too. Now we can check it. So we can go recall 6, recall 4, plus 90 degrees, 180. There it is. I don't know why the light went out, guys, but it did. I think you can see it anyways. So that's it. That's those triangles. That's lesson 3. And we will carry on with some more fun stuff from now on. But anyway, you see, this is, I guess, this is the main thing to really keep in mind. If you have an angle that's greater than 48, you'll have to use the inverse function because you're going over. You do that for this one. This one's bigger than that one, the opposite side. And you'll see that too if you do a 3, 4, 5 triangle. It'll show that. So practice, practice, practice. Thank you very much, and please like and subscribe. And I think hopefully you're getting everybody's getting a good basic understanding of the triangles and how to identify. And like I said before, I apologize if I'm belaboring the issue, but this is the point. You really got to really grab that. Okay, I know how to solve it. I know what elements I need to work with. I know what functions, sine, cosine, tangent I need to work with. Thank you very much, and that's a wrap.